Right now we're going to talk about rules of exponents and radicals. This is an incredibly important topic on the SAT Math section. Let's go over some of the rules really quick. First, if I had the same base with different powers and I was multiplying, a to the b times a to the c would be a to the b plus c. Next, if I had the same base that I had before, but I were raising it to the c power, in that case you'd multiply. Textbooks commonly refer to the red example as product of powers, and the second example as power of a power. Next one. If multiplying means that you add, then dividing means that you subtract. And if raising to an exponent means that you multiply, then taking a root means that you divide. So if I had a to the b and I were taking the c root of that, that would come out to a to the b over c. The way to remember this is that the thing that is in the exponent spot that's on the top remains on the top, and the other number just goes underneath it as a denominator. Now, a couple more examples. If I had a to the b plus a to the b, then that one would be 2a to the b. So I've got two items there, and mathematically I'm just stating the fact that there are two of them. Another common one. What if we had a to the b and the whole thing were raised to the negative 1 power? Well, that one would be just 1 over a to the b. People tend to be really familiar with this without necessarily understanding what it means. A negative exponent means that what you're talking about is on the wrong side of the fraction. If it's in the numerator, it should be in the denominator, and if it's in the denominator, it should go to the numerator. So, if we had a to the b over a to the c, and we raised that to the negative d power, the way to get rid of that negative exponent is by reversing the fraction. So, a to the c and a to the b, now all of that is to the d power. And I can go ahead and apply the exponent. It becomes a to the cd over a to the cb. Now, here's a problem from College Board's 2011 practice test. M is a positive integer, so which of the following is not equal to 2 to the 4th all to the m power? Well, 2 to the 4th to the m power, according to the rules that I just laid out, that's power of a power, so it's 2 to the 4m. Well, that's equal to this one right here, to the choice A. Now 4 to the 2m, well 4 is really 2 squared, so it's really 2 squared to the 2m. And using power of a power, that's 2 to the 4m, so that's also equivalent. 2 to the m times 2 to the 3m. In that one you can use product of powers, so really it's 2 to the m plus 3m, which is really 2 to the 4m. So that's also equivalent. Now 4 to the m times 2 to the m, that's really 2 squared to the m power times 2 to the m, so that would be 2 to the 3m, because in that situation we would add. So that's looking like it's not equivalent. That's looking like it's going to be our answer. But let's go ahead and just look at choice E, 16 to the m power. That would be 2 to the 4th to the m power. So it would be 2 to the 4m power. So that one actually is equivalent. So the correct answer there is that D is not equal to the other choices. Now let's go ahead and look at a problem from College Board's 2001 practice test. 7 to the 10 equals 7 times 7 to the n. Well, 7 to the 10 has to be equal to 7, which is 7 to the first, times 7 to the n, and the product of powers rule would say that 10 has to be equal to 1 plus n. If we take away 1 from both sides, n equals 9. So the choice there is choice B. Here's a problem from College Board's 2007 practice test. 7 to the n times 7 to the third power equals 7 to the 12th. So product of powers, n plus 3 has to equal 12. Take away 3 from both sides, and n equals 9. So that's choice C. Now, here's a problem from College Board's 2007 practice test. X is a positive integer, satisfying the sentence x to the 7th equals k, x to the 9th equals m. We're looking for x to the 11th. So, having done a million of these before, I know that finding x to the 11th has to be the result of combining two numbers that add up to 11. I see that we've got x to the 9th there, and I see that we've got 9 and 7, which if I subtracted them would be x squared. So x to the 9th times x squared is x to the 11th. Now they told us that x to the 9th equals m, and if I can get anything that's equivalent to x squared, then I'll be done with the problem. And the way they laid it out, 9 and 7 have kind of a difference of 2 there, so that's kind of obvious that it should be x to the 9th over x to the 7th, which in terms of the rules that I laid out equals x squared. So we have the m there, x to the 9th equals m, and x to the 7th equals k. So we've got m times m over k, and the answer there is m squared over k. So the correct choice in this problem would be choice A. Here's a problem from College Board's 2004 practice test. N to the k equals 64. N and k are integers. Which could not be a value of n? Well, what powers come out to 64? 2 to the 6th power would be 64. That's probably the easiest of the choices, so that one could be possible value for n. 4 to the 3rd power equals 64. So that's another possible choice for n. So choice C is ruled out. 8 to the 2nd power is 64. So 8 could possibly be a choice. 16 to the smallest possible power we can think of, integer power, which would be 2. Keep in mind that they said that our numbers are integers. Whenever you see the word integer on the SAT, that's totally important. 16 squared would be 256. So we can't get that one to come out to 64. So this is going to be the one that we can't choose. But if we wanted to entertain the idea of the negative 2, well, negative 2 to the 6th power would be negative 2 times itself 6 times. The answer would be positive, and it would be 64. So that one actually works as well. So then the correct answer is A. Here's a problem from College Board's 2002 practice test. 3 to the j equals 27, and 3 to the j plus k equals 243. What's the value of k? 3 to the j equals 27. And if we're thinking about 3 times 3, which would be 9, times another 3 would be 27. So we know that 3 to the 3rd is 27. And what that means is that j equals 3. Now when we go over to the other sentence, 3 to the j plus k to the 3 plus k equals 243. Now on my calculator, I'm just going to figure out 3 to which power equals 243. And it's the fifth power. So 3 to the 3 plus k has to equal 243, which is 3 to the fifth power. So in order to solve this, we had to find like bases. In other words, we had to get these both in terms of 3 to some power. Now that we have it set up that way, it's pretty easy to see that 3 plus k has to be equal to 5. Take away 3 from both sides, and k equals 2. Here's a problem from College Board's 2002 practice test. 3 to the x minus 2 power equals 3. Well, it's a question of 3 to which power equals 3. 3 to the 0 power would be 1, and 3 to the first power equals 3. Therefore, x minus 2 has to equal 1. Add 2 to both sides, and x equals 3. Here's a problem that I came up with myself. 2 to the fourth is equal to b. Which expression is equal to 2 to the 10th? These problems tend to be really difficult because right off the bat you can't tell which direction the question kind of wants you to go. So you might have to try a couple of possibilities. 2 to the 10th is really 2 to the 4th times 2 to the 4th times 2 squared. The reason is that 4 plus 4 plus 2 would equal 10. 2 to the 4th equals b. The other 2 to the 4th also equals b. And 2 squared equals 4. So 2 to the 10th is equal to 4b squared, which is choice E. Here's a problem that involves scientific notation. When 70,000 is written as 7.0 times 10 to the n, what's the value of n? 70,000, if I were going to turn that into scientific notation, it would be 7 times 10 to some power. And to find out that power, I'm going to find out where the decimal is on the 70,000. If I'm dealing with really big numbers, in scientific notation, that's a positive exponent. Really small numbers would be a negative exponent. But to get 70,000 to turn into 7, how many times do I need to move the decimal? 1, 2, 3, 4. So I need to move it 4 spaces over. So it's 7 times 10 to the 4th. So scientific notation is sort of a random application of exponent rules. Here's a problem from College Board's 2002 test. It has to do with the idea of doing the same thing to both sides. In other words, taking exponents and treating them as sort of a regular algebra problem. If 3 plus radical a equals 5.3, what's 3 minus radical a? Well, if this were my algebra problem right here, I could take away 3 from both sides. Now radical a equals 2.3. Now that I have that, to get rid of the radical, I can do the opposite, which is squaring it. Now a equals that took me a while on my calculator there, 5.29. And that's the answer for that problem. Here's a problem from College Board's 2001 practice test. A squared equals b to the 10th times c to the 8th. They're all positive numbers. Most times we ignore these unless it turns out that we're stuck and we need these types of disclaimers later on. Like I always say, those disclaimers usually mean that if you put in 0 or negative numbers, it might ruin the problem. What is a equal to? Okay, so we've got a squared equals b to the 10th and c to the 8th. And if I want to turn a squared into a regular a, I need to do the opposite of squaring it, which is taking the square root. So when I do that, a squared becomes a, and on the other side we get b to the 10th, c to the 8th, and taking the square root is like taking it to the 1/2 power. And power of a power says that I'm going to take the 10 and multiply it by 1/2. Then I'm going to take the 8 and multiply that by 1/2. So 10 times 1/2 is 5. 8 times 1/2 is 4. And a equals b to the 5th times c to the 4th, which is going to be choice D. Here's another problem that I came up with myself to kind of imitate problems that I've seen from College Board. 3 to the a plus 3 to the a plus 2 equals c. Which of the following expressions is equal to 3 to the a plus 3? This is another problem where you might want to try different things here. It's just a matter of looking at this as a regular algebra problem that you might have seen in one of your algebra classes and asking yourself, well, out of the possible things I could do here, which one do I want to try first? The one that stands out to me is that a plus 2 is really 3 to the a times 3 to the 2nd. And I've got everything else remaining the same. Now, if I were looking at that one as polynomial, I see that the first term and the second term both have 3 to the a in them. So algebraically, a logical thing to do would be to factor out a 3 to the a. So factor out a 3 to the a, and it's a question of, well, what does that leave us with? The first one, 3 to the a divided by 3 to the a is just 1. This second term here, 3 to the a times 3 squared, all divided by 3 to the a, leaves us just the 3 squared. And that's still equal to c. So now, 1 plus 9, 3 squared is 9. 1 plus 9 is 10. So 3 to the a times 10 equals c. Therefore, if we divide both sides by 10, 3 to the a equals c over 10. Now that we have that, it's pretty easy to find out 3 to the a plus 3. 3 to the a plus 3 is just, in terms of power of a power, that's actually product of powers, excuse me. That's 3 to the a times 3 to the 3rd power. 3 to the a is c over 10. So it's c over 10 times 3 to the 3rd power, which is 27. So it's 27c over 10, which is equivalent to choice 2. Now we're going to look at some problems that have to do with negative exponents. Here's a problem from a College Board 2004 practice test. X to the minus 1 times h equals 1. So what's h equal to in terms of x? Let's get rid of that negative exponent. A lot of the time, especially on exponent problems, you want to just ask yourself, well, what's a logical thing to do next here? X to the minus 1 means it's on the wrong side of the fraction. So this is really a fraction. And if I want to take that x to the minus 1 and make it x to the positive 1, I need to move it to the other side of the fraction. So now it's just x to the 1 power, to the first power, which equals 1. And I need h. So I'm going to multiply both sides by x. These are going to cancel. So I have h equals x. So what is h in terms of x? Well, h is x. So that's our answer there. Here's another problem that I put together myself. A and B are positive 5b squared times a to the negative 3 equals 45a. What's b to the minus 1 in terms of a? So we need to just do the same thing to both sides until we get b to the minus 1 on one side of the equation. So we can divide both sides by 5, and that gives us b squared times a to the minus 3 power equals 9a. Now I'm going to get rid of the negative exponent because it'll make it easier to see things clearly. B squared over a to the third equals 9a. Now if I need b to the minus 1 power, I need to slowly work toward having just b by itself on one side of the equation. So I'm going to multiply both sides by a to the third, and that gives me b squared equals 9a to the fourth. Now I need b to the minus 1, which is really just 1 over b. So a nice next step would be just to get b by itself. Take the square root of both sides. b equals 3a squared. And if b equals 3a squared, then b to the negative 1 power equals 1 over 3a squared. And 1 over 3a squared is the same as 1 on the top, 3 on the bottom. And if I want to take that a squared and move it to the top, I can put it to the top and call it a to the minus 2 power. So what we have there is equivalent to choice 5. That's our lesson on exponents, on rules of exponents and radicals. This is the SAT MathWiz tutoring service, and I can tutor you online. All you need is a computer with an internet connection, and the first session is free. I would be glad to have the chance to show you what online tutoring with a Yale-educated SAT math specialist is like, and how I can help you to pursue your college dreams. Thanks a lot.